guys, how's it going today? Today we'll be learning about the first two laws that govern the behaviors of gases, Charles' law and Boyle's law. And no, neither of the laws have anything to do with Brooklyn Nine-Nine. Today we will start by looking at the relationship between volume and pressure in a bit more depth. Then we'll use Boyle's law to solve some related problems. After that, we'll turn our attention to the relationship between temperature and volume and apply Charles' law to find a few example problems there as well. Let's get to it. For starters, it's important to understand how these problems are looked at in chemistry. We are usually looking at four major variables when it comes to gases. These variables are temperature, pressure, volume, and number of particles. It helps to keep one or more of these variables constant, and it makes sense this way as well. If you have a bike tire that you want to fill with air, the temperature is going to remain about the same, and the volume of the tire won't change either. Instead, all you'd be changing are the number of gas particles and the pressure. In the case of volume and pressure, which is what we're looking at here, we need to keep the temperature and the number of particles constant. So in this case, we can think of the example of transferring a set amount of gas from one container to another. Boyle's law states that assuming mass, or the number of gas particles, and temperature are kept constant, the volume of a gas varies inversely with pressure. To put that a bit more simply, Boyle's law states that as volume increases, the pressure must decrease a proportional amount, and vice versa. If pressure increases, volume must decrease. The relationship works both ways, as long as mass and temperature remain constant. We can write this law mathematically as V1 times P1 equals V2 times P2, which means that the volume times the pressure in one size container equals the volume times the pressure in a second size container. Let's look at some examples of how this can be used to solve problems. This first question says, a certain amount of gas has a pressure of 100 kilopascals when placed in a 2.0 liter container. What would the pressure of the same gas be in a 1.0 liter container? Remember that our relationship is V1 times P1 equals V2 times P2. In order to solve this, we have to start subbing in the variables that we know. So in the first one, we have 100 is our pressure, and we have 2 is our volume. In the second one, we have 1 as our volume, and we need to solve for P2. So all we have to do is multiply this out, divide both sides by 1, these will cancel, divide by 1, and we get that P2 equals 200 kilopascals. And that's just a unit of pressure, so it's not a huge deal. You might also see atmospheres in some problems, but kilopascals is more common for gas problems. If the gas held in a 3-liter container applies 200 kilopascals of pressure, what size container would it need to be placed in to exert 50 kilopascals of pressure? So in this case, our V1 is going to be 3 times our pressure of 200 equals, we're trying to solve for V2, we don't know that yet, times 50. So again, we'll multiply this out, we'll get 600, and we'll divide both sides by 50, that'll cancel, divide by 50, and we get that V2 equals 12 liters. So hopefully those aren't too bad. Now let's look at the relationship between temperature and volume. To do this, we need to keep the number of gas particles and the pressure constant. When looking at the relationship between temperature and volume, we know that the volume of a fixed mass of gas is directly proportional to its Kelvin temperature if the pressure is kept constant. This is known as Charles' law. It is important to note that the temperature here has to be measured in Kelvin, which is a unit you may not be very familiar with. Kelvin is actually based on the kinetic theory of gases and works out such that 0 degrees Kelvin, also known as absolute zero, is when there is absolutely no motion of gas particles whatsoever. In practice, a temperature in Kelvin is equal to the temperature in Celsius plus 273. Getting back to Charles' law, the simple version of the law is that when volume increases, temperature must also be increasing, assuming that pressure and mass are kept constant. As with Boyle's law, this works in reverse as well. If volume decreases, temperature must also decrease, and so on and so forth. This law can be written mathematically as a V1 over T1 equals V2 over T2, which means that the initial volume of gas divided by its initial temperature will be equal to its changed volume divided by its changed temperature. Let's look at some examples. This problem says the temperature of 3 liters of a gas is 300 Kelvin. Assuming the pressure remains the same, what will be the temperature of the same gas in a 5-liter container? So here we need to remember that our relationship is V1 over T1 equals V2 over T2. And all we have to do is the same as last time. We're just going to sub in our variables. So we have 3 liters for our V1 over 300 degrees Kelvin equals 5 liters over temperature 2. This is what we're trying to figure out. So in order to do this, we kind of have to do some funny math. We'll multiply both sides by T2, multiply by T2, and then we'll need to divide by this whole thing. So we'll get times 300 over 3 times 300 over 3. Cancel, 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 cancel. And we will get that T2 equals 1500 divided by 3, or T2 equals 500 Kelvin. And Kelvin is just written with a K, like that. Second problem says the temperature of 4 liters of gas is 450 Kelvin. What volume of container would the gas have to be in to change the temperature to 600 Kelvin? So again, we've got 4 for our V1 over 450 equals volume 2, which is what we're trying to solve for, over 600. This one's a little easier. We can just multiply both sides by 600. That'll cancel. 600. And we will get that V2 equals 2400 over 450, or about 5.33 liters. That's all we've got for today, so let's get our review on. The 4 major properties or variables that we are concerned with for gases are pressure, mass, temperature, and volume, and all 4 interact with each other in different ways. If we hold one or more of these constant, we can focus on the relationship between 2 variables. Boyle's law describes the relationship between pressure and volume, which is inversely proportional. As pressure goes up, volume goes down, and vice versa. Charles's law describes the relationship between volume and temperature, which is directly proportional. As temperature increases, volume increases, and as volume decreases, so does temperature. That's it for this video. Thanks for watching, and I'll see you next time.